Hello everyone, welcome back. So in today's lesson, we're going to continue on from the area topic of circles, and we're going to work out how to find the area of sectors. Now this is a very similar question to finding the length of an arc, which if you still recall from exercise 8b, where you have to find the proportion of the circle and then you multiply it by the circumference. The only difference this time is rather than finding the circumference, you find the area. So basically to find the area of a sector, you find what proportion it is, multiplied by the area of the circle. That's all you have to do. Alright, so let's take a look at the first example. So for the shape given, determine the fraction of a circle that is drawn, and then you find the area, right? So to find the fraction of a circle that is drawn, you just apply the same method, which you should already know, which is 120 degrees divided by 360 degrees, which is a third of a circle, right? You get a third. To find the area, you just have to do a third times the area of the whole circle, which is a third times pi r squared, which gives you a third times pi times 9.1 squared. Now remember, this 9.1 is the radius, it's not the diameter, okay? So because the diameter is the distance between one side of a circle to the other side, the radius is the distance between one side of a circle to the center. So in this case, this is the center. And that's how you get the area, and because it says nearest centimeter squared, you just round it to the nearest centimeter squared. Alright, so let's just do an easy question just to start it off, and then before doing some, well, these are also easy questions, but slightly more difficult. So let's have a look at 6a. Oops. Make the pen a bit more thin. 6a. So it says complete and calculate the area of part of a circle with radius 7.4 centimeters and an angle of 150 degrees. So the first step, work out the fraction of the circle, which is 150 degrees over what? 360 degrees. And this should equal to, okay, I'm going to do this in my head, but you don't need to. 5/12 of a circle. You can just type this into your calculator and it will simplify for you. Now to work out the area, which is part B, area is equal to the fraction of the circle, which is 5/12, multiplied by pi r squared. So pi times r squared, right? Now what is the radius? Radius is 7.4. So we just do 5/12 times pi times 7.4 squared, which gives you, well, actually it tells you the answer here, but you can just type it into your calculator. So just type in 5/12 times pi times 7.4 squared. Remember there's a squared here, so which is 71.68. So yeah, that's basically 72, right? So 72 centimeters squared. Alright, so that's how you can do question 6. Now, there'll be some more of these questions here, so let's take a look at question 7a. Now 7a, now, even though they don't give you what angle it is, it's pretty obvious that this is half a circle, right? So if it's obvious that it's a half a circle, we can just say fraction is equal to a half, right? Now to find the area, you just do fraction multiplied by pi r squared, which equals to half times, now what's the radius in this circle? Is the radius 4 or is it 8? Well, it's 4, because remember, radius is the distance between the edge of the circle to the center. So the radius is 4. So substitute 4 for r. And this should give you, now the question says nearest centimeter squared, so just round it to the nearest number and that's all you have to do. So half times pi, shift pi, times 4 squared. What does this give you? 25. So nearest number is 25. And once you get the answer, write the units. So what's the units? The units is centimeter squared. Right. So that's that. I'm going to let you do the rest because I feel like this is pretty straightforward. So I don't need to go through too many examples before you get the idea. Alright, now let's move on to some slightly more challenging questions. So let's take a look at question 4. Now this is composite shape, and composite shape is probably going to be challenging because it's a topic that you guys had some trouble with in the past. Okay, so the question says calculate the area of the composite figure correct to one decimal place. But basically, when you want to work out the area of a composite shape, just split the shape up into the shapes that you can work out. and then you do it, right? So if you look at this shape, you know that this is made up of a semicircle and a triangle, right? So as you can see, they split it up into area 1 and area 2. So all you have to do is find the area 1, which is half a circle, and you can do this by doing half times pi r squared, right? Because this is just half a circle. So it's just pi r squared divided by 2. That's just the same as half times pi r squared. So you get 10.6 because the radius is what? Remember, the radius of this circle is actually not 5.2. 5.2 is the diameter. Radius is that length there. So that's how they got the 2.6, because 2.6 is half of the diameter. Now, area 2, I'm not going to go through because I expect you to know how to find the area of a triangle. It's just half times base times height, right? So that's how you can do that. Once you get the two areas, you can add them up and you get your answer. All right, so that's a bit challenging, but it's just basically 2 questions in one. So I'm just going to go through maybe 2 of these examples just to make it clear to you. So let's take a look at 8a. Okay, so I'm going to copy this question just so I can explain it, but it's actually not that difficult. It just needs a bit of practice and then you should be good to go. All right. So remember, this is a composite shape because it's made up of a semicircle and a rectangle, right? So how do we work out the area of the semicircle? Well, we know that, okay, so area is equal to area 1 plus area 2, right? So we can actually write them out in one step. How do you find the half of a semicircle? Half of a circle. We know that half of a circle is going to be half times by the area of a circle, right? So pi r squared plus, what's area 2? Area 2 is just this rectangle here. So this is going to be 12.4 times 3. Right. Okay. Now the next part is, how do you determine the radius of this semicircle? Well, we know that 12.4 is going to be the diameter, right? Because this length, this is the distance between one side of a circle to the other side. So to find the radius, we need to halve the 12.4. 12.4 divided by 2, which gives you 6.3. It gives you 6.2, right? So then we have to substitute the radius into here. So we get half times pi times 6.2 squared plus 12.4 times 3, right? And for this, you can just type the whole thing into your calculator and you get your answer. So let's take a look. So half times pi times 6.2 squared plus the area of the rectangle, which is 12.4 times 3. You get 98, right? Because it says correct to, is it the nearest number? Oh, 1 decimal place. Okay, so then 97.6 centimeters squared. Okay, so I'm just going to give you a recommendation here. When it comes to doing these questions, it's better to write out the whole step in one go rather than working them out separately and then adding them up. The reason I'm saying this is because when you write them out separately, you have to round each to 1 decimal place and then you add them together and round them again. So what I recommend is you only do one rounding and that's in your final step. So don't do what the textbook does, because if you do it this way, you sometimes can get your answer that's a little bit off than the actual answer. So just write out the whole expression in one go and you get your correct answer. Alright, so let me take a look at question C. Okay, question C is a little bit more challenging, so let's just take a look. So, to do question C, remember, we need to split the shape up into 2 shapes that we can work out the areas of, and this is just basically 2 semicircles, right? So you have your area 1 and you have your area 2, right? So then we can just say area is equal to area 1 plus area 2. So how do we work out the area of area 1? Well, area 1 is just half a circle, right? So it's just going to be half times pi r squared. Now, rather than writing out pi r squared, I'm actually just going to work out what the I is. So let's work out what the I is. So we know that this length is also going to be 5, right? So that means the diameter of area 1 circle is going to be 5. So then what's the radius going to be? Well, the radius is just going to be half of 5, which is 2.5, right? So that's going to be 2.5 squared plus area 2. Area 2 is also going to be half times the area of a circle, which is half times pi times Now, what's the radius of this bigger semicircle? The radius is going to be 5, right? So then you just do half times pi times 5 squared. And that's your answer. You just have to type this up into your calculator. So I'm just going to explain it again because I did kind of do a lot of things in one go. But basically, to find area 1, you know that this is half of a circle. And the radius of that circle is 2.5. Because we know that the diameter is equal to 5. The radius is equal to 2.5, right? And to find out the area of area 2, you have a semicircle. But the radius of this semicircle is going to be 5, right? Because the radius of the big semicircle is 5. Radius of the small semicircle is 2.5. So just to make it a bit more clear, we can say that this length is 2.5, right? And this length is 5. So that should be more clear. Okay. So then once you get to this step, then the question becomes easier. Just type it into your calculator. So just going to do it again. So half times pi. It's a lot of numbers to type, so make sure you get used to that. Plus half times pi times 5 squared. So you get 49.1, right? Because 1 decimal place. Centimeters squared. Alright, so hopefully this is quite clear, and feel free to take a few more steps if that's required, but once you get used to doing it in this kind of fashion, you realize these questions are actually not too bad. Alright, so let's take a look at a slightly harder one. So question, say, we can just take a look at question H, okay? Alright, so let's take a look at question H. How do we do H? Okay, so we've got to split this up into two shapes. So I'm going to split it up into this quarter circle and this square, right? So then area is equal to A1 plus A2. So how do you find the area of A1? So we know that A1 is just going to be a quarter of a circle, right? So it's going to be a quarter times pi r squared. Now what's the radius of this quarter circle? The radius is just going to be this length, right? Because that's the length from the outer edge to the center. So this is 8.5. So that's the area of the quarter circle plus, so quarter circle, plus the area of a square. Now area of a square I don't need to teach you, it's just 8.5 squared, right? Because it's just this shape here. So this is a square. Alright, so then how do you find this out? Just type it into your calculator. So you have 1/4 times pi shift pi times 8.5 squared plus 8.5 squared. You get 128. Okay, so to round this to 1 decimal place, you got to do 129.0, right? So 129.0. And the units should be centimeters squared. Okay, so hopefully, I mean, I'm not going to do all these questions because that would just ruin the fun for you. So I've picked some random ones like A, C, and H. And hopefully by looking at these three, you kind of get an idea of how to do the rest. Alright. Now I'm going to move on to some even more difficult questions where in these questions, you need to, rather than doing one area plus another area, you have to do one area, subtract another area. So let's take a look. For this donut looking shape, how do you find the area of the shaded region? Well, you can think of it as big circle take away small circle, right? And that's how you get the area. So what they did was they found the area of the big circle, which is pi r squared, take away the area of the small circle, which is also pi r squared. But you have to notice the difference is that both circles have a different radius. The big circle has a radius of 11 divided by 2, which is 5.5. And the smaller circle has a radius of 5 divided by 2, because we know that 5 is going to be the diameter, right? So then pi times 2.5 squared, and we get the answer. Okay, and question B is a little bit more tricky because question B is area of a semicircle take away area of a small semicircle. So it's basically the same thing. The only difference is you have to halve each of the areas. So that's how you get the answer. Alright, so with that in mind, I'm just going to do a few examples and hopefully it becomes quite clear what you need to do. So I'm just going to do question B. Afterward, question B is basically the same as the example. Just going to get rid of this, make a better snippet. Okay, so how do you do this? So remember, to find the area of this donut shape, you just do area is equal to area 1 take away area 2, which is outside circle, which is pi times r squared. Now what's the radius of the outer circle? Well, the outer circle has a diameter of 5, so the radius is going to be what? 5 over 2, right? Which is 2.5. So pi times 2.5 squared. Take away the area of the smaller circle, which is pi times the radius of the smaller circle, and that's going to be what? This length here, right? So this is going to be half of 3, which is 1.5. So this is big circle, and this is the area of the small circle. And basically just type this up into your calculator and you have your answer. So I'm just going to type it up. So shift pi times 2.5 squared. Oops. Shift pi times 2.5 squared. Take away pi times 1.5 squared. And you get 12.56. So one decimal place is 12.6. Okay, so that's pretty clear. Do a slightly harder one, so a semicircle, right? So to find the area of a, well, this is like a rock melon slice, if you want to think of it that way. Alright, so you just do the same thing. Area is equal to the big semicircle, take away the small semicircle. Now remember, to find the area of a semicircle, you have to do half times pi times the radius squared, right? So what's the radius of the big semicircle? Well, it's just going to be 7.9 divided by 2. So 7.9 divided by 2 should give you 3.95. Okay, so you can use a calculator for this. I'm just doing this in my head. So 3.95 squared. Take away half of the small semicircle, right? So what's the radius of the small semicircle? That's going to be 2.9 divided by 2. Which equals to 1.45. Okay, so times pi times 1.45 squared. So that's how you get the area. Remember, this is the area of the big semicircle. So big semicircle, and this is the area of the small semicircle, right? So just to make it clear, the area of the big semicircle is this whole thing. The area of the small semicircle is this area. Okay, so you just have to do big take away small and you get the answer. So what does this give you? Well, it's just a lot of calculator work. It's not actually difficult, but just very annoying. So you just do half. Make sure you type everything correctly. Times pi times 3.95 squared. Take away half times pi times 1.45 squared. And you get 21.2, right, centimeters squared. Alright, so I think that should be kind of clear. Okay, I'm just going to do one more then, just to like, so you guys have the full understanding. I'll just do F, okay? So for this one, I mean, they didn't go through this example in the textbook, but it should be quite obvious what you need to do here. So the area of the shaded part is equal to, okay, well, as always, we just write A1 take away A2. Now, what's A1 going to be? Well, A1 is just going to be this rectangle, right? Yes? Is it clear? It's a rectangle, right? So to work out the area of the rectangle, we just do 10.3 times 14.7. Take away the area of the what? The circle, right? So then you get the shaded area. So area of a circle is pi times the radius. What's the radius? 4.8 pi r squared. And that's your answer. So just type this up and you get it. So it's actually pretty easy if you know what to do. It's 14.7. Take away pi times 4.8 squared, which is 79.0, right? Because 2 is less than 5, so it's 79.0 centimeters squared. Okay, so I think that should be all for today. So just to recap today's lesson. So in today's lesson, we've worked out how to find the area of a sector. So that's what we started off with. Once we've learned how to find the area of a sector, then we can find the area of a composite shape, which is one step above, by combining two areas or more than two areas in some of these cases. After we found the area of composite shapes, we found the area of these. These are also composite shapes, but to work out the area of these composite shapes, you need to find an area of a big shape, take away the area of a small shape. So that should be all for today. If you have any questions, just feel free to send me a message. Thank you for listening.